Today, I'm delighted to be hosting the two co-authors of the Driverless Endgame. We have Andrew Miller from Hatch and Bern Grush, the Executive Director of the Urban Robotics Foundation. I'm the Managing Director of the Urban Robotics Foundation, and I'm your MC for the session. I'll be facilitating the Q&A and monitoring the chat during the session. The vision for the Urban Robotics Foundation, which was founded in 2021, is urban livability and universal accessibility, supported by safe public area mobile robot services. So we focus on international standards, educational and advisory programs for municipal deployment, rules of behavior, and traffic orchestration of public area mobile robots. I'm not going to go through all the material on this slide, but I did just want to give you a quick overview. We are a global member-funded nonprofit, and we hope that you will consider joining us if that's appropriate for your organization. And I'm now going to hand it over to actually Andrew, who's going to start the webinar and cover some material about Hatch.
Good day, everybody. Welcome to the webinar. It's a pleasure for us to be here to speak to you, and me in particular. I am a senior leader with the Urban Solutions team at Hatch. If you don't know us, Hatch is the world's largest privately held consulting firm. Our global headquarters is in Toronto, in the Greater Toronto area, but we have offices all across the world on every continent, including Antarctica. And I myself work closely with colleagues in New York, London, Melbourne, and elsewhere, because the issues that we work on, how to build better cities and better urban mobility, are truly global in scope. The Hatch is guided by our manifesto, which guides everything we do. This is a portion of it here. Our vision, our mission, our values, and our personality. I'll only say here that part of the mission that resonates with me is we strive to apply ourselves to the world's toughest challenges. And I think the regulation and policy for automated driving certainly fits that category. That's why we're all here today. So the report, the Driverless Endgame, which I and Bern co-wrote with help from some of my other colleagues at Hatch, we should be clear up front. Bern and I know something about the technology of automated driving, but we are not technologists. We are, okay, I won't speak for Bern. I'm not a technologist. I'm a policy specialist, because policy is where the work needs to happen. The technology is, depending on who you speak to, ready for prime time, being deployed today in cities around the world, particularly China and the United States. But whether it is policy ready, given the amount of pushback that public officials and regulators in California are providing, even as we speak, to taxi bot operations in those cities, policy readiness is not here yet. So in our report, we considered 10 different areas, far too many to speak about today. We're going to speak specifically about liability and insurance on my part. And then Bern will have something to say about the digitalization of rules of the road, enforcement and first responders. And given that this is the Urban Robotics Foundation, robots are never far from the mind here. If you're interested in some of these other things, we could certainly ask questions. We would encourage you to obtain a copy of the report from that link to the left and read it, because we think it is got valuable things to say on all these subjects. Not just things to say, but specific recommendations. We made 43 recommendations to the regulator on how to prepare for automated driving. 43 is a lot, but that's because so little has been done in this space. Regulators have an immense amount of ground to cover on this subject. So let's begin by talking about liability, specifically for ADS, which is our shorthand for an automated driving system. We hear a lot about autonomous vehicles. We tend to avoid that. We speak of vehicles with an automated driving system, or an ADS for short. An ADS system is immensely complicated, and it depends upon the contributions of many, many players to make the system as a whole work. Every player has got a different role. That role can be affected by errors that others make. But there's the problem. No one is going to want to be responsible for the functioning of the system as a whole. No one's going to want to be liable for it. but there must be clear and simple allocation of liability for the technology to be useful. Let's dive into this. Subrogation for automated driving systems. Subrogation is a term that you might not be familiar with. It's a jargon from the insurance industry. Subrogation is to assume the responsibility for a debt from someone else. So the way that insurance works today, and will work in a certain way in the future, is that if there is an incident between me and another driver, the insurance companies make us whole to the extent that there is injury, and then they just battle it out amongst themselves for determination of who is going to pay for this and in which amount. So we already have a sophisticated subrogation system, a subrogation system that could conceivably, when there's an incident, retain compensation from an ADS manufacturer if there's a problem. This is a good approach because it takes it out of the hands of individuals and puts it in the hands of institutions and organizations that are better equipped to handle it. Or so it would seem, because assigning fault is going to be much more difficult in the future subrogation process than it is at present. Today, before the advent of widespread ADS, there's a limited number of factors that can be involved. Principally, the driver of the one vehicle, the driver of the other, and some other external variables. Mechanical, were the tires broken? Is there weather? Is it a no-fault regime? But as the length of the list on the right, the column on the right indicates, it doubles and trebles in an ADS world. It's still the case that I could be at fault because I haven't maintained my vehicle. The other driver could be at fault because they might be driving. They might be in a period of mixed driving when both human and ADS are piloting vehicles on the street. All the same factors of our world, if I can call it that, apply, but also the sensors. Are the sensors working well? Who manufactured them? The software. Is the software working well? Who manufactured it or the subsystem of it? Infrastructure may play a part, particularly if municipalities have infrastructure that is beaming instructions to connected vehicles. And then there's the role of a teleoperator. We'll speak more about teleoperation later, but if a vehicle has a teleoperator, someone remote who can assume operation of the vehicle at a distance, which we think is going to be a necessity, that's just another ingredient in this stew of confusion. So liability is going to evolve. It's going to move from where it largely resides today with the human behind the wheel of the car, the owner or the driver or the user, towards the vehicle maker or the manufacturer of the ADS itself. Subrogation is going to have to handle all these complex multi-party issues I described. So I suppose the good news is that for humans that are being born about in ADS vehicles, much of this will be the iceberg. It'll be below the water. They won't see it. It'll be many more actors battling it out in the subrogation process behind the scenes. But it's going to be expensive. That's the issue, is the more complex subrogation gets, the more rates are going to have to rise, particularly after incidents, to handle it. So maybe ADS does not invent a world of consumer-facing complexity, but it does invite a world of consumer-facing costs, an issue that is, we think, underappreciated. Another issue that is underappreciated, and critically so, given its importance, is where liability switches. You can think of liability as the egg balanced on the rooftop. It's going to fall down one side or the other, but which side? So the illustration here is not our illustration. Bern and I didn't make this. We took this directly from the Society of Automotive Engineers standard, the American engineering body that is most well known for thinking through this space. They're the ones that coined the famous terms level 1 through level 5 vehicle. You will go to that's the SAE standard. You will look in vain for a discussion of liability, because it's not, they're engineers, they're not concerned with it, but we are. So we have taken their image and we have imposed that red box around the image because we think it illustrates the key point where liability is in question. I won't rehearse what levels are. I think if you come to this seminar, I think you're familiar with that sort of language. But if a vehicle is at level 2 or below, it is still a human vehicle with some driver assist features. The human is always the responsible party. If it's a level 5 vehicle, so far the putative theoretical level 5 that can handle all driving itself and might not even have a steering wheel, that is all the manufacturer's responsibility. No human in the vehicle would ever be responsible. The issue falls in the zone between level 3 and level 4. The robotaxis that are currently plying the streets of San Francisco and Austin are level 4. So this is not a theoretical discussion. This is the sort of vehicle we're going to be talking about for the next few slides. So the SAE standard defines the role of a fallback driver. There has to be one for vehicles of this sort. When the ADS encounters a system that it cannot handle or believes itself human would be better equipped to handle it, it will either bring the vehicle to the minimal risk condition, i.e. the place where of least risk, which would in most cases be stopped in a stable position outside of traffic. Or if it can't feel that it, but what if it can't feel that it can do that? Well, it can prompt the human, who is the fallback driver, to do it. And if the human doesn't respond, it'll try to do it itself. But if the human does respond, the human takes over and resumes responsibility for driving, or what the standard calls the dynamic driving. What if there's no passenger to service fallback drive? What if the passenger is unable to service fallback drive because the passenger is a child, or the passenger isn't licensed, or the passenger has just had a debilitating medical event? On this, the standard is silent. Again, appropriately, it's an engineering standard, but it's something that's very important for us thinking through liability. Let's look at it closely. So let's imagine first a situation where the human driver wants to turn on the automated driving system. So the human asks for it to start. The system checks to make sure that it's where it is in an area it can handle its operational design domain. And then it takes over. It's more fantastical, but we can also imagine a system where the ADS sees that the car is about to enter an ADS only lane, an AV only lane. It informs the human that it intends to switch over. So there is a switching period before neither the human nor the ADS is fully in charge. It's moving from one to the other. That switching period is tricky. It's even trickier when you're thinking about a situation where you're going from the driving system to the human system. You could imagine that the vehicle, I outlined earlier a situation where the vehicle determines it's in a situation, an ODD it no longer can handle, switches over to a human or attempts to. But it goes the other way too. What if a human says to the ADS, move over, robot, I'm going to take the wheel? You'd assume that a human would only do that if they are capable of taking it on. But what if they're mistaken? What if they suffer that debilitating incident after they press the button? What does all this mean for liability assignment? What does it mean for insurance subrogation? Particularly, how long is that period of switching and who is responsible during it? There are many questions. When can we allow a human to decide whether to turn an ADS on or off? Is a human reliably capable of determining whether that's appropriate? Should that be something that we test drivers on? Is a machine capable of doing this? How would we know? And how will insurance handle all of this? I'm sure that you'd like me to go to the next slide and give you answers to all these questions. If only I could do that. Like I said, this is the most complex and least studied matter having to do with the advent of automated driving. Much work needs to be done, and the regulators are going to have to be heavily involved. Bern and I have made some recommendations that we think stand. I will not elucidate all of these now. For full elucidation, please do read the report. But we think that regulators are going to need to define the appropriate language around these capabilities of what can be switched by when, by whom, and when, how long it will take, establish event lines for responsibility, and work with their insurance regimes to make sure that these are going to be respected, that they're not going to have to be tested first in very fraught court battles. The one recommendation I would highlight, the one in red at the bottom, is the most urgent, which is we must prevent marketing of driver assist systems with misleading language. Like, for instance, if there was a company out there that was billing its driver assist as full self-driving, not saying there is such a company, but if there was, I think that would be a real problem. It would be false advertising that could lead to over-reliance on a system that can't handle it, that could quite easily lead to lives lost, and may hypothetically already have done so. This is something that jurisdictions should be rushing the legislature back into session to handle today. I'll lay that down as our first marker of recommendations. Much more needs to be done, although with not quite that level of urgency. So that's all that we have time to speak about liability today. We could do a whole seminar on that, I think. But now I'm going to turn the slide over to Bern to discuss, at first, digitalization of the rules of the road.
Thanks, Andrew, and thanks everybody for your time today. Really appreciate your interest in these topics. First of all, when we think about digitalized driving that Andrew has just been speaking about, and all the drawings and ideas that he was showing would have digital metrics and in digital involvement, and of course, automated driving is a digital activity. But there's a lot of rules that are going to be guided, whether they're all the way from freight rules. I'm not going to read all of these, or road work rules, or VRU stands for vulnerable road users. So there's a whole body of rules. They also have to be digitalized as well, because as a vehicle, a digital vehicle without a driver has to get its rules from somewhere. And we'll talk about how we do that now and how we do that in the future. So now, today, with the exception of a few hundred robo-taxis in California and Austin, accepting those, all the rest of us drive with using rules of the road, or we've been trained. Most of us use a good deal of common sense, we hope. Unless you're a backseat driver, the driver's not using common sense, but otherwise, these are the kinds of things, knowledge of the road, just simply driving experience, paying attention. These are all the things on the right that you have to engage in to drive as a human driver. And what you're doing while you're driving, besides trying to stay on the road, is that you have signs and signals and lanes to follow and obey and so forth. And if you don't, we have police and fines to remind you that you weren't behaving and so forth. So all of these things together, we call them the analog world of how it is that you drive today. So again, this is all repeated on the left, on the left circle, the same things that you just saw, how humans drive. But in the future, and going back to what you just learned from Andrew, there will be rules of the road. I'm going to talk about those in a minute. We hope they're very similar to the rules of the road that we have now. We've seen places where there's been a mismatch already, but all these other things, the training and the knowledge and the attention and the skill, all those things are all embedded in software or machine learning or high definition maps and all that sort of thing that absorbs all of that capability that you as a driver have. And now we're going to have a car. You can use the word automated driving as ADS, and you can think of it as AI, although it's not really AI, but all those arguments aside, that's what's going to take over your role. And where are the signs and signals and lanes at? So you know that some vehicles can read signs, or we expect them all to read lines on the road, but it turns out that there's most of these vehicles get some help from what's called V2X, or vehicle to infrastructure, that provides more data to those vehicles and so forth. Now, given a future of, let's say, a growing majority of ADS, I'm not saying when, decades, whenever, we're not going to be having police officers, human police officers, chasing down vehicles and giving them a ticket for a bad left turn or whatever. This is going to be done with sensors of some kind or another, not fully resolved yet. And we're not going to necessarily give them fines. I mean, as an example, what happened in California, in San Francisco, on several robo-taxis were blocking traffic, and there was a great deal of concern about that. And just a few weeks ago, the state passed the permission for those fleets to double their fleets or to increase their fleets. It doesn't matter, but the state said, go ahead, put some more in. And very shortly thereafter, there was some more incidents of blocking more first respond, blocking fire trucks and ambulances and so forth. And so what the state did was they asked that particular fleet to cut their fleet in half. So that's not exactly a recall, and it's not quite a fine, but you can appreciate that. What does the government do in the future when cars aren't behaving well? Giving you a ticket for a red light is not how that's going to happen. So we don't know how that's going to happen either. I mean, all of these things are so far unresolved. So what we want to make sure of on the right-hand side, that these rules are trustworthy, that they're current, that they're machine interpretable, obviously. And one of the major issues today is that how we generate digital rules, because some of our rules of the road are digitally encoded into the software of these machines. And where they come from is that they come from our analog rules. And so basically, we're sort of making a digital twin of our analog rules. I'm going to talk to you in the next slides about how that will fail and how that has to be reversed. And whether it has to be reversed in 10 years or 40 years, that's not the issue, but we can't continue translating from analog to digital as we go forward in the future. So I need to introduce you first to an ISO draft standard. That CD stands for committee draft, so it's quite high up on its drafting. So the fundamental drafting is finished. It's in its final throes of criticism. It's a technical standard. That's what the TS stands for, and that's the number of the standard, the 24315. It is called Management of Electronic Traffic Regulations. And it is a body of rules that ensure that the rules as expressed to vehicles, and I showed you in the earlier slide all the other participants, including cyclists and cars with drivers and roadside systems, and even, if you may have noticed in that drawing, even robots as well, sidewalk robots as well. So all of those rules have to be trustworthy and secure and authoritative. And I think you can appreciate that if we're going to share a complex body of electronic rules with a variety of systems, and you'll see even with the court system and even with the policing system. So it's not just sending these rules to a vehicle. It's these rules need to be common throughout. So it's all of the uses of the road network. All of these rules have to have these properties. And they need to include in their scope static rules, you can see here, as such as speed limits, dynamic rules, for example, at construction, for instance. And it also needs to incorporate existing standards as well. And it needs to involve all vehicles, not just motor vehicles. It includes cyclists and pedestrians and robots and micromobility and so forth. We all need to share the same rule base. Well, how do we determine and manage and forward those rules to all parties? Here's the scheme. This is directly from the meter document. I'm pronouncing meter, METR as meter. You can see at the very bottom, there's a GitHub location. It's highly technical, but you can go and see there's a some documents you can download from there that are completely readable. And I've taken that drawing from one of those documents. So starting from the left, there's many sources of rules of the road. You can appreciate that there might be local sources like the speed limit around a school zone. There might be regional sources such as, all highways above so many lanes have a minimum and maximum road speed, for example. That might be a regional guideline. There's national guidelines as well. However those rules are originated, they need to be pulled in through a translation process because there's different sources, and those sources are in different formats, and they arrive from a different source process. They all have to be pulled together. This is an ongoing, consistent process that goes on forever. It never stops, because as the local regulator changes something, it has to go through this process. It comes to a collector, and it's that collector that wants to make everything, as I outlined before, wants to make everything trustworthy, secure, current, connected. All those sorts of things happen at the collector, at which point coming out of the collector, and that's where the key issue is, coming out of the collector goes to a disseminator, and that disseminator is common for all parties. So you see some of the parties, such as vehicle or the traveler or enforcement agency, you could put the courts in there, you could put the traffic sensors in there, you could put the red light cameras in there. So every aspect of what are the rules, what are the interpretation of the rules, all come to those end users. So the end users is a large, disparate group of end users, not just and only the vehicles themselves. So it's this collector and disseminator that's the standard itself, and the schedule for that. Now, this particular illustration is already 2.5 years old. Because I collaborate with this same working group, I don't write this standard, but I come to meetings and review this standard. So I know that the system requirements are pretty well nearly done. In other words, this schedule is on track. That's important for people listening. And the reason for that is that by mid-2024 or late 2024, you'll be able to write, not you personally, but it will be possible to begin writing these systems. I know there's already people working on parts of it, but that we will have a capability to deploy these systems probably within a year or something like that. But anyway, that's not the issue when it's coming. My point is that it's on schedule, and it is a sort of a critical component. So here is the last slide about meter, and I understand that these are very small fonts, but what I'm pointing out to you is that there are 5 components. If you go look at what appears to be the y-axis, it's not actually a Cartesian coordinate, because what this is displaying is that there's 5 components. There's a process component, an organization component, a technology component, an information component, a culture component. All 5 of these have stages and steps that migrate toward this upper right corners, the actual automated distribution of these rules of the road, RORs, rules of the road. So we're now in this outer fringe. The process is we're manually collecting rules. We have imperfect coding, for example, or the technology itself is, best practices, and that's where we are now. I just showed you concepts for the meter architecture. That's where we would be. So if you were engaged in this is what you would be looking at now. There are gaps already. How will those be closed, and so forth? So the next round, which we will be entering in 2024 or 2025, is the actual setting out processes for digitalization. For example, which organization will take responsibility? One of the things in the document that Andrew and I wrote is we spoke about. We won't be talking about that today, but we spoke about a automated vehicle office that would take responsibility, and that office, if that recommendation is accepted, would take responsibility for this and so forth. So you can snap this screen and study it later. We won't be able to go through the whole thing, but this whole process is in process, and by the time we get up to this upper right corner is absolutely 2 years away, in my opinion. That's just an opinion. It could be more, and it will take a while to disseminate. So, it might be in California earlier than it will be in, Ontario, for example, but it is a process that can't be avoided. And if you don't do meter, then what are you going to do? You're going to do something. My proposal to you is to do meter. Anyway, here are the recommendations for digitalization before I go on to the next two sessions. Obviously, to maximize the harmonization. I think you can appreciate the system's already complicated. If we have different rules, even if there's minor differences from jurisdiction to another, as you were to drive from one jurisdiction to another, that would be a complexity. We talk about that at some length elsewhere in this report, but not today. We absolutely need to make sure the rules are identical for humans and ADS. It's not going to work to go to court with a human and an ADS and they had different rules. I don't think I need to explain why that's not workable. So that's part of the harmonization issue, is because as we make these ADS, we don't want to have a different ADS for every jurisdiction and so on. And the life is complex enough. So harmonization needs to be complete. We're highly harmonized, but we're not complete. We need to have a master source for these in digital form. I won't belabor this, but right now we take whatever we do in the analog world and we translate that to the digital world. And what it means is that we have many analog processes: courts, signage, roads, rules, user training, police trainings, all analog training. There needs to be a single digital source, and all that needs to be translated out into those various analog forms. Okay, let me go to enforcement quickly. It's much a shorter element here. And this is, what does enforcement actually look like? Obviously, it does not look like that in the cartoon. We're coming into, I mentioned already, we already have the issue of some amount of disorganization in San Francisco because of blocking first responders. And so we need emergency protocols already, because as soon as you have one robo-taxi in your city, you have mixed human and ADS. And if you have 300 or 400 of them, you're already in a mixed environment if you were to drive in that city and so forth. There's been talk of dedicated lanes. You cannot do that everywhere. It's not even thinkable to do that everywhere. And even if you did it everywhere, you still need to cross over. I mean, wherever we have bicycle lanes, cars park on them, pedestrians cross them. So dedicated lanes is a very limited solution, very limited solution. So no matter what happens, this is going to be a long and painful transition, multiple decades transition, until we get to a place where it's almost only ADS. I underscore this. We're not going to get to a pure forever only ADS, because there will always be vehicles that are not worth automating. You have very special construction of vehicles. For example, this is not worth automating them, and they have to move in this space. There may be a very tiny proportion of them, but they won't be zero. That's an important thing to understand. And so we will have, there's insurance issues, there's these meter issues and so forth. So going down to the bottom of these two columns, right now we're going toward common digital rules. We're not there yet. We've already started, and over these next years, we're going to be going to common digital rules, and those rules become embedded. Not just embedded in the vehicles, they may be embedded in the traffic enforcement system, they may be embedded in the court systems, it may be embedded in automated citation systems. I don't know how much, but they will be embedded. And last point to make, no matter what we do, no matter how amazing we get on the right-hand side, there's always going to be human first responders. How are we going to manage that? Because however highly automated our environment gets and all the rules and digitalization and so forth, there's human first responders out in those spaces. And it's very, very much a concern that we ensure, for example, that absolutely the first responder understands specific vehicle risks. Already today, there might be a vehicle risk of a battery fire in an EV, for example. We may solve all of that, but as first responders approach, they need to understand, is this vehicle going to remain stopped? Is this vehicle in risk of an energy mishap? They must have access to vehicle control. I don't care, electronic or physical. They have to be able to seize and halt and stop and know that vehicle's safe. We don't have rules for all that yet, except for the obvious that we have to do that. Throughout that, the teleoperator is going to be safety critical. I don't know if the teleoperator is always going to be human. I'm not talking about 80 years from now when the teleoperator is also automated, but today and for the foreseeable future, teleoperator is going to be human, and that's an expense, and they need to be absolutely available, microsecond available, not available in 10 minutes, not available to drive out to the scene, but they must be available as soon as the first responder calls for them. And no matter what, that teleoperator must be compliant. Now we have a problem if the teleoperator has been commandeered by a malicious force or a malicious actor. How do we enforce that compliance? So these are issues that will have problems as we go forward. There's a lot of recommendations about enforcement. You can refer to the report at the bottom, but basically we need to have a very rapid remote ID, and that the reason is that as the first responder is approaching the scene, they need to be able to somehow ID the vehicle sufficiently to understand the circumstances that might be special for that circumstance or that vehicle. I already mentioned it, teleoperator rules and maximizing harmonization. I don't think that's new to this talk. My last conversation, just a few slides, I want to introduce public area mobile robots. Many of you already know about the URF work in this area, but briefly, they're ground-based, so not drones. They're on the ground, and we don't care if they're wheels or legs, but they're a robot that does not have a human inside or on top or riding on it, so that these humans are using it. This human is just passing by. This human is not involved with this robot. This human is accepting a delivery from this robot, but it's not operating the robot. So all of these robots are either teleoperated or automated in some version or another, and they're not just outside. This is inside of the building, for example, could be mopping a floor, and so on. Most these other ones are mostly outside, but we don't care if it's indoors or outdoors. What matters is that the space has pedestrians in it. And anyway, I'll move on to say there's a lot of opportunities for these. Briefly, there's delivery opportunities. Everybody appreciates the potential value of that. There's robots that patrol or surveil. These have a neighborhood safety aspect. So does keeping our streets, so does salting the sidewalk creates neighborhood safety from ice, for example. So sidewalk maintenance or street maintenance or curb maintenance all matters. By the way, it's not listed here, but one of the capabilities is they can issue parking tickets, for example. So that would be not exactly parking maintenance, it's actually parking management. But nonetheless, these are all the kinds of opportunities. The major one I like to point out to is that if these devices proliferate, that will create commercial pressure for ADA compliance. Any place that has sub-ADA compliant sidewalks, for example, or have absolute minimum, there's going to be pressure to widen sidewalks. That, I think, is a value, and I like to see that we consider the collaboration between those two regulatory aspects, the sort of the safety and capability of these devices and the orchestration of these devices and ADA compliance. And in fact, I'd like to see minimum ADA is not good enough. That needs to be greater. Anybody in the accessibility domain knows that. There's a lot of risks. I think you can appreciate that there is fear. One of the cities, more than one city, has banned them temporarily because citizens have complained. The complaints are currently unwarranted, but fear is fear. Fear is a real thing. And so you can't wave off someone's fear, because if you're a blind or deaf or in a wheelchair, that fear is well-founded. Not because of the technology, but it's because you, as such a person, have challenges. And so we need to respect this fear and uncertainty is the point that I'm making. And so you can't wave it away. In any case, I want to point out that road crossing is the largest area of concern. There have been numerous robots hit while crossing. No human has been harmed that we know of. However, it's possible for a robot that's struck to become a projectile. And that is clearly a dangerous circumstance. So at some point, there's going to be a wake-up call about road crossing as well. Of course, right now, the operators are very, very cautious, but still, it has happened. The problem is right turn on red. That's where most of the problems are coming from. You can take a screen snapshot of this, but the standard that we are working on, we are the project leaders of the standard, has multiple elements, safety elements, behavioral elements, procedural elements, post-crash procedural elements, elements to do with certification for the various potential environmental circumstances and so forth. So that is all part of that standards work. So our recommendations, my last slide, the recommendations are that if you're interested in these issues, you consult with your accessibility people. If you're in a city, you have accessibility interests, you need to consult there. You need to consult with those logistics firms that want to do last mile delivery. You need to consult with the appropriate people in municipal planning, and you want to consult with robotics experts of what's possible and how they can be sure of safety and so forth in order for you to design or determine a model code. When I say a model code, that's going to look, if you're a city, that's going to look like it's going to look like a bylaw. But if you're a province or a state, it's going to look like a House bill in the states or addition to the Highway Traffic Act in other countries and so forth. So that depends. So what you want to do is you want to make sure, if you're going to deploy, that you're considering readiness, like your readiness, your infrastructure readiness, your team readiness, and your traffic enforcement readiness, accessibility readiness, the infrastructure itself. Are your sidewalks actually suitable? Is your governance ready? Again, that's bylaws and so forth. And do you have a project team? Again, all of this is down at the bottom. You can snap this. It's the same document we've been pointing to you throughout. So that's a thank you. Just to stop there, and I'll leave this up. Lee, you can take back over.
Wonderful. Thank you so much, Bern. And we do have some questions in the chat. So I'm going to go through those now. And I'll start with the first question came from Ellen. And this is for you, I believe, Andrew. How will liability for algorithm bias be assigned?
So if the answer is how will it be assigned, that's going to depend an awful lot on a lot of factors. So if you'll permit me, I'll answer a different question of how should it be assigned. Algorithmic bias is a feature. It is, if we abstract away from the political for a moment, it is a bug in the system. It's the algorithm behaving in ways that a reason, the legal standard would be a reasonable person would not do. That's an error. So if to the extent that we identify algorithmic bias, that is a fault of the algorithm owner, and it'll be correct, it should be corrected through the subrogation system, giving them every incentive to fix it. So the question will be, how do we identify algorithmic bias? How do we prove it in judicial proceeding such that damages could be found and awarded? A trickier thing, but when you pull the camera back, if you accept that algorithmic bias is a problem and that we all agree that it's a problem, then it is no more egregious than any other bug in an operating system and will have to be found and rooted out.
Okay, why don't we stop sharing altogether, Bern, and we can just go to gallery view. People are welcome to turn on their cameras if they want. And I do have a couple of other questions here. So Steve, I'm not sure how to pronounce your last name, Zaka, asks, regarding the liability piece, is the insurance industry a part of the conversation, and what is their position? What is the OEM's position? And there are probably many positions in that regard. There may not be just one, but again, this is the liability part, Andrew, so I'll have you start there, and Bern, you might want to add something as well.
Yeah, I think this is from my old colleague Steve Chaika. It's a pleasure to have you here, Steve. So your question is, if regarding the liabilities, the insurance industry a part of the conversation? What is their position? What is the OEM's position? So the insurance industry they are doing some thinking in this regard. Bern and I interviewed a few people as part of the research for ultimately this document that we've prepared. The insurance industry's position is I think again, you don't hold me liable for this, speaking of liability, but my understanding of their position is that they think that their subrogation processes can handle it, but they're going to need access to the relevant information in order for the subrogation process to do its part. The OEM position is murkier, and it depends on which OEM. Some regard the workings of their systems as proprietary and commercial and don't want to let that data become available. And you didn't ask, but some jurisdictions push on this and some don't. The most pungent example of this is that in California, when there is an incident involving an automated vehicle, those can be publicly obtained through request to their on file with the government agency, and you can seek them out. Texas does not require this, so therefore it is not publicly available. If there's an incident, relevant data will be turned over insofar as the OEM thinks that it is relevant. It's a clear place where a strong, firm guidance from a regulator about what is irrespective of commercial confidentiality, when matters of safety come up, the relevant information has to be turned over to interested parties. It's a regulation I think we would do well to adopt in other jurisdictions.
Thank you. Steve, does that answer your question? Oh, good. Thumbs up. Okay, and then a question from Patrick Hilberg. The traditional unit of business for automobiles is private ownership. What do you envision as the AV unit of business? Do we buy from GM? Do we lease trips, aka Uber?
The answer is all of the above. There's another project that Andrew and I are working on with a third person, and we're trying to answer that question. So, and our way of asking the question is, when ADS is perfected, that's a when, we think it will be, or nearly so. The question is, what will the ending proportion of passenger kilometers traveled be in a privately owned vehicle versus a for hire vehicle? Because you probably know, Patrick, that there's been reports, if you're aware of Tony Seba way back, I don't know what, 7 or 8 years ago, wrote a report that 95% of all passenger kilometers traveled would be in a robo-taxi by the year 2030 worldwide, which is beyond absurd. It's ridiculous on every count, but that was actually believed by a number of readers. It was a very convincing report. And it's also very clear that's been said that, well, once you get an automated vehicle, then everybody can have one. Even if I don't have a license and I'm 12 years old, or I'm 95 years old and the doctor's taken my license away. So now everybody can have a vehicle. So the range of reports has been from everybody's going to have their own vehicle to no one's going to have their own vehicle. The truth is in between, obviously. That doesn't take much to figure that out. And here's what we think is looking like. It looks like we're going to move away from, country by country is different. So in North America, it's not only a single digit, but it's low single digit. Like in the United States, it's less than 5% in for hire passenger kilometers traveled. We think that's going to move up to 20 or 25%, but it's not going to get to 50% and 80%, all those numbers that have been reported. We don't believe that. But it's a longer argument, Patrick, and maybe we'll get you to ask you to review the book that Andrew and I are working on.
Certainly.
Okay, great. I'm going to now move on to a question from Adam Beck. Have there been any challenges or issues identified regarding wireless connectivity in the right of way, and any particular minimum standards or level of performance that may be required?
Bern, I'll defer to you to this one, as one who's done more international standards work than I have.
Wow. That is not an area that I can speak to. It's actually a very important question, but I don't know the answer.
Okay. We will take that question and come back to you, Adam, with some research when we have an answer for you. And now a question from Martin Nathanson. Is your ISO working group making a concerted effort to align specifications with V2X standards from SAE, IEEE, ETSI, CAMP? A huge swath of these standards are already set up national, international standards for encoding and distribution of transportation information.
So there's two answers to that. In our, well, what's in common for the two answers is the answer is that we are assuming that those standards are in place and respected. In other words, we refer to them. Part of my answer is because in the standard for the public area mobile robots, we are using those standards to cross the street, for example. So in other words, we simply refer to those standards we don't rewrite them and we don't defend them. We simply refer to them and then we show how they're used. That's in the robotic crossing aspect. In the work that Andrew and I just finished, we assume those standards are in place and we don't recommend that they be changed, or we don't recommend that they be ignored in any way. We assume they're there and we're silent about any changes.
My question was whether the ISO working group is trying to align its specifications with those standards.
So the answer is it does.
Yes or no, or you don't know.
Yeah, no, it does. So the SAE and the SAE and the ISO work very closely together. For example, my team, part of the leadership team that I report to in the ISO actually reports to the SAE. So I'm saying we're tightly aligned.
Okay, so I can assume that if I looked at the documents, the drafts, that there would be a clear delineation of what constitutes something new with respect to these V2X standards, what constitutes something that overlaps. Would there be actual explicit reference in the specification document to how anything in this ISO spec relates to any of these standards?
So I can only answer that for the 4448. The answer is yes. It's expressly referring to specific SAE standards for SPAT and MAP, if you know those two. But in the meter standard, I don't know. I would have to search through those documents to see if there's any reference to SAE. I do know that they won't contradict each other. That won't work.
No, of course it won't work. But I would suggest I would put forward something that was worth consideration, which is that SPAT and MAP are all very well, but the most important standard the most important IEEE standard, in my view, is the one that deals with trustworthiness of messages, and that's 1609.2. And in what you presented regarding the issue of how to rely, and in how you presented this whole question of the reliability and the trustworthiness of information that would need to be exchanged to basically communicate about these rules, I think there's a great deal that's already built in. There's a lot of the things that you're presenting as unanswered questions. That's my opinion. So the whole business of how to ensure that vehicles and infrastructure and even V2X equipped vulnerable road users, if that happens, can rely on and trust the information they're exchanging in real time, that's already covered. And so if you say that there are all these unanswered questions, I would suggest that a lot of what you're saying are unanswered questions are already effectively answered in IEEE 1609.
So I want to be careful, because I spoke about two standards. I spoke about this robot standard. I think that's not what you're talking about. I think you're talking about meter. And meter is, yes. Meter is talking about how the order in which information is collected and disseminated, and how it is that we ensure the order of these things are disseminated. So it doesn't change any of the rules. It wouldn't contradict anything. If I understand your question, it wouldn't contradict anything that you're concerned about. And it doesn't need to repeat any of that. It just simply needs to refer to it.
Okay.
Sorry, I'm not an expert in meter to the extent that your question might be asking. So what I can do is I can get you those documents.
Yeah, so I'm going to suggest that we take that offline. I think it's a really valuable and in-depth conversation around the IEEE standard and how that might relate. I mean, it's a really good follow-up, and we might have another session. And Martin, sounds like you have some expertise with, I guess you work with P3 mobility, so you may have some expertise that could contribute to the whole conversation. So we have reached the end of our allotted time. So I want to thank everybody for attending today. I will send out a follow-up email with a copy of the recording, and we'll put a blog post on our website with a link with the slide deck, so you'll be able to get a hot link. I believe most of you have probably already downloaded the white paper, but if you haven't, we also have that link that will be included, and that goes directly to the Hatch website. So thank you to our guest speakers, and thank you to our attendees today, and have a great rest of your day. Thank you very much.
Thanks, everybody.